Alright guys, this is binary fractions, another video. We're gonna talk a little bit about precision in binary fractions. When you turn decimal fraction into binary fractions, what's going on with that precision? Okay, for example, to start, I'll show you how fractions are written in binary system. So this is my radix point. So for example, this is a 1 0 1, this is my decimal part, and that's beyond that dot is my fraction. And how to write a fraction, if, for example, I have something like 1 1 1 1 1 1 1 0 0 1 1, or maybe it's too long, so I'll show you like that. So here in the first position after my comma or dot, I have 1 second, 1 fourth, 1 eighth. These are fractions, yeah. Half, quarter, 1.20, 0.125, 1 16th, 1 32nd, yeah. So as you maybe see, this is nothing else like my numbers, whatever I have here in binary system. So it's a multiplication of 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Here what I'm gonna have, 164, 128. For example, 0, 1. And what if I'm counting my fraction, I have to add whatever is here. So 1.2 plus 1.4 plus 1.8, or maybe I'm gonna do like this. 1 second plus 1 4 plus 1 8 plus 1 16 plus this one. I'm not gonna take down because it's 0 plus 1 128. Sorry, what? 128. I need all of this, and I'm gonna get my fraction. So that's the introduction, how to write fractions in binary system. But what's gonna happen if I'm gonna get a fraction like 0.025, for example? It's a very small fraction, and probably it doesn't exist in my, like you see before, 1 second, 1 fourth, 1 eighth. This is not precise fraction. It's not something like 0, like 0.5, which is 1 second, or 0.25, which is 1 fourth. So it is something totally different, something we're gonna have problem with. And it's gonna give us a little bit long binary fraction. So let's start the process like we did before. We take our fraction 0.025, multiply by 2 to get the binary fraction. We're gonna get something like 0.05. I take my decimal place, which is 0, and after radix I'm gonna write 0. That's gonna be my binary fraction here. That's gonna be my binary fraction. So let's write proper 0, not a shitty one. So I have 0 because that 0 is here. Now what we have to do, we have to take the remainder. Sorry, that's the remainder, 0.5. Write it down here, 0.05. Again, times 2. What we're gonna get? We're gonna get 0.10. So I still have my decimal place is 0. So I'm gonna transfer the 0 here. I'm gonna take the remainder, 0.10 times 2. This is 0.20 or 0.2, as you wish. So take my decimal place, I'm gonna write it down here. And maybe I will write down my steps. This is step 1, step 2, step 3. So this is step 1, step 2, step 3, step 4, 5, 6, 7, 8, 9, 10, and let's say 11. Let's do 11 steps. 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 steps. Believe me or not, but we're gonna go through all these steps. So we take the reminder, 0.20 times 2 equals 0.40. Is have 0 on the fourth step, because that's the fourth step. I'm gonna write that 0 from here, and I'll take the reminder and we'll transfer it to 0.40 to step 5 times 2 again, 0.8. Yeah, 0.8 or 0.80, that's the same. I take decimal, write it out, 5 step. Reminder, 0.8 times 2 is 1.6. Wow, I'm gonna get my first 1 from step 6. I'm gonna write it down here. Take the reminder, 0.6 times 2, 1.2. Wow, got another one. Take the reminder to step 8, 0.2 times 2, 0.4. I have 0 right now here. Reminder, step 9, 0 times 2, 0.8. And maybe you can see something, what's happening here. I have 2, 4, 8, and I had the same story just here. Yeah, here on step 5 and step 6. So I have, what I have left is 0.8. I'm gonna transfer it here, 0.8 times 2, 1.6. I take my 1. Reminder, 0.6. You see, it's the same story happening here. On step 7, I have the same story. Times 2 is 1.2. I take 1 to step 11. Reminder, even if I want to go further, step 2, 0.2 times 2. But this is the same story here, and I'm gonna stuck in that kind of loop basically forever, because like I said, that precision is quite special thing with fraction. It's gonna be very hard to get exactly to 0.95. I might get something like 0.024987621, something freaky, but probably I'll never get to that 0.25, but I'm gonna be very close to that. So that's the fraction, very long one, 11 steps. If I want to go further, 0 times 2 equals 0.4. I'm gonna write that 0 here on step 12, and I can go so on and so on. So that's gonna last forever, and probably I'll never get to that 0.25. And if you know languages like Java and double, that's the type of variable, numeric type, and is a float kind of type with the fractions. So if you want to write like 2, so in double it's going to be 2.0, and 2.5 is 2.5. Like you have integer, it's impossible to write 2.5 because it doesn't have decimal places. Integer is going to be just 2, not 20, nothing like that, just 2. Yeah, but doubles going to be 2.5, 2.78, whatever you have. And if you go deep in that kind of type and fractions, you might notice that we have the same rule like here, because we might never get exactly to that value, but we can be close to it, close. So sometimes we have to check conditions, not like a equals whatever 0.025, but if a is close to that number, yeah, we have to compare it. We have to create like very small float, sorry, double variable, for example, and we're gonna give it like after comma we're gonna give like, after like 100 places we're gonna give 1 or whatever, some small number, very tiny number. We're gonna compare if a is close to that n variable, but it's never gonna equal to n, or never is gonna equal to 0.25. Yeah, so bear that in mind. Like, fractions in binary systems are a very unique thing. You might never gonna get exactly what you want to get, but you can be very, very close to that. Depend what kind of precision number you will get. Like, you know, float type is not used in Java too much because it's not that precise. We're gonna use often double to write the floating number in Java. See you in the next video. I hope you understand all that freaky process of creating fractions in binary systems, and maybe it does help you. So see you in the next video.